we need to find relative extrema for a function. And when you're doing this, regardless of if you're doing the first derivative test or the second derivative test like we're going to, your first step either way is going to be to figure out where the derivative, the first derivative, equals 0, or where the first derivative doesn't exist. It's undefined. We won't have any t values where this first derivative is undefined because, quite frankly, with a polynomial function, you'll always have defined results. You can plug in anything for t here, you'll get a legitimate number back. So we just have to figure out where g prime equals 0. We're going to have to factor, and specifically we're going to have to factor by grouping because we have 4 terms. So I'm going to just factor out a 2t squared from the first couple of terms, which leaves me with t minus 1 left over. The last 2 terms, they don't really have anything you could factor out. So I'm just going to factor out a negative 1, I guess, technically. And that would also leave me with t minus 1 left over. So now I have 2 new terms. I can factor those by taking out the t minus 1 common factor. That would leave me with 2t squared left over in the first term and minus 1 left over in the second. So we can see that t equals 1 would be a critical number that would make the first factor equal 0. I think if you end up solving the second factor for 0, you'd get t equals plus and minus, it'd be square root of 1/2, which if you rationalize it is square root 2 over 2. And to properly use the second derivative test to see if these are max or mins or what, you would have to plug each of these directly into the second derivative. I'll start with the easy one, g prime of 1. G double prime of 1 is 6 minus 4 minus 1. That's a positive result. G double prime of negative square root 2 over 2. All right. So I've got to square that fraction. Squaring a negative will give me a positive. Squaring the top gives me 2. Squaring the bottom gives me 4. 2/4 is a half. 4 times square root 2 over 2. We'll see the 4 over 2 simplify to 2. Oh, this is negative. Minus 1. As a result, we get 3. This is now plus 2 square roots of 2 minus 1. That's going to be positive as well. Putting in positive square root 2 over 2 is going to give you very similar terms, except we will now have a minus in the middle term. Everything else will stay the same. That result is negative. So that tells me g is concave up at t is 1. A concave up graph would yield a min if there were to be any extrema. We are also concave up at negative square root 2 over 2. So there will be a min occurring there. And we are concave down at positive square root 2 over 2, so there will be a max occurring. So in words, you would want to say something along the lines of t equals negative square root 2 over 2 or t equals 1. Both give relative minimums because g double prime of 1 and g double prime of negative square root 2 over 2 are both positive. And you would want to say that square root 2 over 2 yields a relative max for g because g double prime of square root 2 over 2 is negative.